Are we on the air? Yes. Hi, welcome to the Orion Bionetworks webinar series. This is a monthly program sponsored by Orion Bionetworks for the brain research and information technology community. Orion Bionetworks is a nonprofit research alliance whose mission is to accelerate time to cure for brain diseases through the power of shared data and predictive analytics. Before I introduce today's speaker, let me walk you through some logistics. This program is being recorded and will be archived in the Orion Bionetworks YouTube channel and website. The presentation will be approximately half an hour in length to allow 15 to 20 minutes for Q&A. Please use the chat buttons on the left to post a question to the presenter at the end of the presentation. Today our speaker is Dr. Renee Deehan, who joined Solventa, which is a personalized medicine company specializing in large-scale molecular and clinical data, in 2006. She's the head of research, and she develops and executes a scientific strategy for Solventa's internal discovery programs, as well as providing consulting services. Before she was at Solventa, Dr. Deehan earned her PhD in molecular and cell biology at the University of California, Berkeley, and holds a bachelor's in engineering from the University of Pennsylvania, which is also where I got my bachelor's of engineering. In her spare time, Renee also competes in a new combination Olympic sport we call gymnastics crew. It's kind of like doing yoga on a stand-up board. In this webinar, Dr. Kenny will discuss a blood-based predictive decision tool for rheumatologists called ClarifyRA. This diagnostic provides a molecular measure of patients' disease activity, but also information about the likelihood of response to treatment. We hope that this type of approach can be adopted for brain-related diseases as well. I will now turn it over to Dr. Kenny. Thank you very much.
Thank you very much, Magali, and thank you to Orion for having me here. I'm really excited to give everyone this talk, and I'll be giving a pretty high-level overview, and if there are any questions I can't answer, then you can certainly email me, and I will make sure that I get the answers to you. So I'll just give you a little bit of a corporate overview before we launch into some of the market challenges and the actual science. So as Magali mentioned, I come from Solventa. We were founded in 2002. We're here in Cambridge, about 25 people, so we're a small biotech company. We do two different things. First of all, we are a scientific consulting company, so we work with a lot of large pharma and biotech companies to try and help them understand some of their personalized medicine issues. And at the same time, we use our own technology platform to do our own development, and I'll talk about one of our development projects today, which is ClarifyRA. What the platform does is it's very good at taking large-scale data and reducing it down to molecular mechanisms that the scientists can then try and evaluate in the context of whatever experiment that they're looking at. So we do a lot of trying to identify major mechanisms that actually cause a disease. We do a lot of biomarker development, which will be part of the story today. We like to understand how mechanisms differ across diseases and use that for line expansion, and then both prognostic and predictive biomarker development. So what I'll be talking today about is rheumatoid arthritis, and what we're trying to do is figure out a way to holistically analyze big data and then generate something that ends up being diagnostically actionable for the rheumatologist. And that's the main basis of precision medicine, as you guys all know. But in general, 50% of all prescribed drugs are either useless or dangerous to patients. And these can cause all types of adverse events. So, there's a real need to identify the right drug for the right patient and really use it at the right time. I think that RA is really an ideal market for this because $5 billion a year in the US alone are just spent on RA drugs that do not work. Autoimmune disease requires a long-term care, so we really need to be thoughtful about how these patients are being treated. And in terms of the market for diagnostics, I think there's a lot of room open for an RA because there's not a lot being used currently outside of some of the standard molecular measures and disease scoring. So the challenge that we're dealing with is that RA treatments are effective in less than half of the patients, and it can take upwards of 2 years for a lot of patients to find a drug that's actually going to work for them. And there's not a lot of differentiation by efficacy or safety for the current therapies that are either in late phase clinical trials or on the market in terms of targeted therapies. And that's mostly what we'll be talking about today. The diagnostic that we're developing is really intended to be used in patients that have moderate to severe RA. This slide probably needs to be updated, but it just goes to show you all of the different targeted therapies that are in clinical trials or are being marketed for rheumatoid arthritis. And the good news is there are a lot of things on this list if you compare it to a disease like SLE, where there's really not many choices available. What we're looking at here is almost a challenge then for the rheumatologist to figure out which one is the appropriate one to give the patient. And this is just to give you kind of an idea of what it might be like to actually have RA and to face some of these challenges. We spoke with Andrew Lumpkin, who is a stats professor out on the West Coast, and he blogs about his disease and how he manages his disease. And we had a lot of really great conversations with Andrew, and he really helped us understand kind of what his day-to-day life was like. He's on 3 current RA medications, but I think the key thing here is to look at the list of former medications that he had been on. Cimzia, Humira, both of those are anti-TNFs, as is Remicade, and Enbrel. So even just in one class alone, he tried 4 different therapies. And so, he was really interested in the idea of having something that would have helped him, maybe eliminate some of the time that he spent taking therapies that didn't work. Okay? So, we think that this type of test would be interesting both to patients, but also to physicians and payers. And, payers certainly don't want to spend a lot of money providing treatments for providing inefficacious treatments. But I really think that most importantly for the patients and physicians who want to see their patients do well, rheumatoid arthritis is a progressive disease, and the longer you spend being inappropriately treated, the higher a chance there is that your disease is going to progress in a way that really won't necessarily be able to be reversed. So I think it's important that patients really waste as little time as possible being treated. So what we wanted to do was create a holistic diagnostic that would enable us not only to look at a patient's disease activity, but would also enable us to start giving the physician information about what type of therapy might be beneficial to the patient. And our first focus was on predicting non-response in the largest class of therapies, which is anti-TNFs. And I'll go through the treatment algorithm in a scenario. And the idea here is that the patient would, show up at the rheumatologist. There would be options that are explored in terms of potential therapies. You could take a blood sample, the lab test would be performed, a report generated, and then that would go back to the physician, who could then be informed and help their patient decide which avenue they wanted to choose. So the current treatment algorithm for RA looks like this. A patient presents, they are typically treated with methotrexate and steroids, so DMARD-based therapies. 40% of patients will respond, 60% will not respond. When you become non-responsive to this cocktail of medications, then that's when typically you're moved on to a biologic. The first biologic that is taken is in the U.S. is often Humira, but there are other anti-TNF therapies that are also on the market, like Remicade and Simponi and Cimzia. And what will often happen is when a patient fails to respond to the first anti-TNF, they're actually moved to another anti-TNF. So that's a real challenge because patients like Andrew can end up in a cycle of continuing to take anti-TNF therapy and never actually responding to them. And one of the goals, the first goals that we have, is to be able to identify those patients before they ever really take an anti-TNF, or even after they take their first anti-TNF, so they can then consider moving on to other targeted mechanism therapies, okay, like tocilizumab and abatacept. So, that's really what this diagram is showing here, is we're really trying to kind of eliminate the anti-TNF cycle with ClarifyRA. What does this actually look like? And the story that I'm going to tell you today is really simply about infliximab, because that's the data that we have available to us. But so the first generation of the product, our goal is to focus just on anti-TNF therapies, and maybe also look at disease activity. But the subsequent generations of the product, we would like to be able to make evaluations about other classes like anti-IL-6s, et cetera, like the JAK therapies, beyond just looking at the TNF class. In terms of the technology background, and we can come back to this at the end if there are more questions as well, what Solventa has tried to do is create a platform where we use a lot of transcriptomic data and then integrate other types of data into it. So we have kind of this holistic picture of what's happening in the cells, in the system. I think that a lot of diagnostics, there's a huge emphasis on DNA-seq, and that can work in a lot of diseases. I think that RA is going to end up being one of those diseases where we're probably going to have to look beyond just DNA and try and understand the whole molecular picture. So that's where we come in. Our approach can be broken down into three separate elements here. And the first element is curation. So we've spent the last 11 years manually curating information into a knowledge base. And we have algorithms that can, very smartly query that knowledge base. And that yields, what we call mechanisms. So this might be the kinase activity of MAPK13, or it might be the transcriptional activity of the NF-kappa B complex. But what it will enable you to do is to tell whether that activity for a given protein is being activated or attenuated in a given patient, in a given experiment, etc. So in terms of actually getting this information into the knowledge base, we use something called BEL, which stands for Biological Expression Language. And BEL it's free to anybody who would like to use this language. It's open source, so you can go to openbel.org. And the idea is that it's a language that enables you to very easily capture biological information from text and then, hold it and use that for computation later on. So an example of how you might capture a piece of information or knowledge from, we only use published sources, so peer-reviewed published sources. So that's the only thing, all of the information in our knowledge bases come from mostly papers and some books here and there. But in this case, we have the sentence, IL-1 beta exposure resulted in HER2 activation in human epithelial cells, and that increased the conductance across a monolayer of airway epithelial cells. So what we would capture from that sentence is the following. We would capture the protein activity of IL-1 beta, and we have the ability to use lots of different domains and knowledge bases in terms of databases in terms of protein activity and kinase activity and things like that. We capture the relationship. In this case, it's in increases. And then the object here. So it's the kinase activity of the protein ERBB2, HER2. We can also capture information about the context of where this came from. So, for example, we would capture that it came from human. We would capture that it came from epithelial cells, and specifically we would identify in the paper whether it came from primary epithelial cells or whether we were using a cell line, in which case which cell line, etc. So the knowledge base itself contains over 600,000 of these statements, and one of these things that you see right here would be considered a statement from over 45,000 peer-reviewed publications. So there's a lot of information in there, and we use BEL to represent that knowledge. We're able to capture lots of different types of functions. So, in the last example, we looked at protein abundance. We looked at an activity. We looked at the kinase activity specifically. We can also capture processes like cell migration, modifications, so phosphorylation events, and other type of modifications. Also gene abundance, the mRNA expression of. So it enables us to be very rich about that. And I'll talk about this next. The next thing that we want to do is to be able to really query that knowledge base and, take data. If we have a data set, be able to map it into the knowledge base and use our algorithms to query it and kind of resolve that data down into mechanisms. So I'll show you some examples of the types of algorithms that we look at here. So we might ask, if we think about TNF as a signal, as a signaling pathway. So, we can ask in a given experiment or patient, is there a presence of TNF signal using a richness metric? We can think about whether TNF is being increased in activity or decreased in activity. So really the direction of signaling. And that's just a standard binomial distribution. We can look at the strength of the signal, and this is what we're going to talk a lot about today, is looking at the strength of this TNF signal in that patient. Is there a little bit of TNF? Is there a lot of TNF? What it enables you to do is get a score for the amount of signaling in one patient versus another. And then you can use that in classifier development as a feature. We do a lot of translatability. Okay, does TNF signaling in the lung look similar to TNF signaling in the colon, or is it a little bit different? And then some larger network scoring. There are cases where we'll build large disease networks to try and understand what's going on. Specifically, in terms of the whole genome, in terms of the strength metric, we use whole genome expression data for this, and we reverse engineer it to infer a measure of strength. So if we have a given mechanism here, we could say it's TNF. We have these relationships that exist in our knowledge base. So we know from prior knowledge and different other experiments that people have done that TNF can positively regulate the mRNA expression of this gene, this gene, this gene, and this gene, and negatively regulate the expression of genes 5 through 8, for example. For TNF specifically, we have hundreds of things that we know it regulates. What we do is we take the geometric mean of the fold changes in our experiment for all of the ones that we're interested in underneath a given mechanism. It takes the directionality into account. So, for example, in your experiment, is gene 5 actually being decreased in abundance? And if so, then it counts positively towards the score. If indeed it's being increased, and that's contrary to what we know from our knowledge base, then that counts against the score. And it enables us to collect a quantitative value for each patient. So, if this is an example of the fold changes of these 8 genes, all of them are consistent with what we have seen before in the literature. This would say that patient 1 has a high level of TNF signaling relative to patient 2, who has lower fold changes and some going in a direction that are not consistent with prior knowledge. And we can talk about that. There's, of course, some caveats that come up with that, and we'd be happy to talk about that. So what we wanted to do here is look at public data, because that's what we had available to us, where patients have been treated with infliximab, and whole blood samples were taken before treatment with infliximab. These are all RA patients. We looked at 4 different studies that contained anywhere between 15 and 44 patients, so not a lot of patients. So actually combining these data was actually something important for us to do. That had a distribution of responders and non-responders, and we used the response calls that were provided within the manuscripts and the publications themselves. So typically these were, response was determined at 14 to 16 weeks. It was EULAR scoring. That was the criteria that was used for the studies. And then we have the references here if you guys want to look them up. So we generated a linear model of 18 relevant signaling mechanisms that were able to stratify patients for response compared to non-response. So all of these were done on different microarray platforms, and it was mRNA expression data that went into it. So what we do is we generate, these thousands of mechanisms in using our knowledge base and our technology, and we have strength scores for all of those mechanisms. And then for each patient that's shown here, and so for all of these thousands of mechanisms and the thousands of scores that go with them, we use that as input rather than just using the gene expression data alone. We sort of roll up all of that gene expression into the mechanism level. We have the scores for the mechanism, and that's what goes into the model. This particular one contains 1,489 underlying genes that underlie these 18 relevant signaling mechanisms. And what we would want to do moving forward is probably reduce that number of features down to less than 100. So we're going through some exercises to be able to do that now. Another piece to this, and we'll get to it later, but really what we need are more patients in order to develop an optimal classifier. We still think that there's room for improvement here. So if we stratify patients for their classifier score, so the classifier score is going to be, measuring the fold changes of these 1,489 genes. And we stratify for their ClarifyRA score. We see here's all of the patients from each of the 4 studies that have been stratified. The non-responders are colored in yellow, and the responders are colored gray. This, if I'm showing you, is repeated tenfold cross-validation, and that was used to assess the performance. Our idea here was to try and optimize for specificity, for non-response specificity, because if you're the rheumatologist, you want to be very sure that you're making the right decision not to treat your patient with infliximab. So we really wanted to optimize in that direction. So what we're able to do in terms of the sensitivity was about 30%, 30 to 40%. So, our idea here is that we would be able to identify 1/3 of non-responders with a high degree of specificity. Another thing that we looked at was actually the uncertainty in DAS28 scoring. The overall ORAC for this was, I think, 72%. And we were curious about what would be the optimal performance given some errors in DAS28 scoring. And we saw that that's about 90%. So that's the best that we could do. DAS28 does include some subjective measures that vary from patient to patient in terms of reporting, and therefore from rheumatologist to rheumatologist in terms of reporting as well. So that's something to take into consideration. I think that tenfold cross-validation is a good way to assess performance, but it's probably the most optimistic of testing methods. And so what we also wanted to do was we had 4 different data sets. So our goal here was to train on 3 and then test on the 4th one completely independently. So this will provide us with a more conservative assessment of performance. So this was lead 1 batch out cross-validation. The mean performance was similar to tenfold cross-validation with 94% specificity and almost 70% precision. Of course, there's significant variability that you're seeing here, probably likely due to the small number of samples in each set. We did a comparison of other published classifiers, and we tried to do this in the most fair way possible. So we used the selected published genes that were actually, listed in the paper, and used the clustering methods from each of the papers, because the purpose of the papers that we used, of the data sets, was the same, really, to try and use microarray data to develop a predictor of infliximab response, to retrain on each of the 4 blood data sets. We left out Julia 8 because this was retrained on the remaining 3 because it was actually developed using one of the 4 other data sets, so we didn't want to be unfair there. And then this performance was evaluated by cross-validation. So, the classifiers actually all perform relatively similarly, and ClarifyRA performs a little bit better with an ORAC of around 70%, and the other ones kind of hover a little over 50%. So, we did an exercise to see if we could determine whether additional data would provide us with potential performance benefits. And this is really important because part of our next steps is to acquire another data set that can be used to actually improve the performance. And we wanted to make sure that this was actually a sensible thing to do. So we do see with the current data set in terms of, training on lower amounts of data than we already have, do we see a positive trajectory in terms of performance improvements? And, we do. So we do think that adding more samples should potentially help. In terms of doing a biological analysis of the mechanisms that are driving ClarifyRA, we see there's 18 mechanisms, as I mentioned earlier, and depending on which platform is being measured for them, this corresponds to a little over 1,100 to almost 1,400 underlying genes. So a lot of genes to look at. These mechanisms are listed below, and we see that they're involved in response to wounding. We see that it's an immune defense response, and these are all things that are high in the responders. They're development-based, so FOXA2, MICE1, NF1, etc. There's an interesting sort of neural component that we're catching here as well, which we need to investigate further. And then some other mechanisms where there's a little bit less known in CDQ2, which of course is something that's often seen in proliferating cells. We also did a gene-based analysis, and that pointed to TNF and FKB B signaling in the responders, and an increase in the expression of genes involved in lipid and drug metabolism pathways in the non-responders. So something we were considering was really a drug metabolism issue for some of the patients. Another portion of the test is the disease activity component, and I can really only share some high-level details about this unless we happen to have an NDA with you, which we may. And so we're calling this ClarifyRA disease activity, and this is another whole blood-based multimodal marker because it combines the measurements taken for CRP with mRNA measurements. We trained a model to predict DAS28 scores using 260 patients. It was a proprietary cohort. We used random forest in this case to develop the classifier and incorporated the CRP protein measurement. So we've been able to independently test this in over 580 patients from 2 other independent studies. So that's been great. We're going to continue testing that as well. It would be really wonderful to get a disease activity biomarker that was not reliant on CRP measurements. And so that's sort of what we're going to try and tackle next. So just to wrap up, in terms of ClarifyRA, the first pass at this holistic diagnostic, we really would love to see additional data to determine whether we can predict response to improve the prediction in terms of response to infliximab, but also to determine whether this is just a class effect or is it something that's actually very specific to infliximab. Our goal is to really be able to obtain data from other targeted therapies, IL-6 therapies, JAK2 therapies, etc. Some of the B-cell dependent ones like Rencia. So we would love to see if we can develop something that is really going to point a patient in a direction for a particular class rather than just looking at infliximab. We actually will be testing ClarifyRA on a non-infliximab cohort, and so that should help us answer the question. As probably many of you know, there are always some challenges working with public data sets in that you're beholden to whatever's been published. And only one of the 4 data sets actually published the DAS28 scores for the patients. And so it'd be really nice if we could calculate the delta DAS scores and see if ClarifyRA is correlated with those, rather than relying on the measures of response and non-response, which in most cases was non-response versus moderate and very good responders. So anybody who's worked on RA understands the challenge with moderate responders in terms of evaluating them in the context of a placebo response. So it's hard to train a classifier to objective measures of response that can be a little bit fuzzy, of course. And we're not a diagnostics company. We don't have a lab. So we're looking to partner with a diagnostics company that would be able to help us there. Okay, so just as a summary, this test provides molecular information about disease activity, and that element has been tested and trained and tested in over 800 patient samples. So our prediction here is really based on infliximab. I think we would like to see if it predicts non-response to other anti-TNF therapies. We're hoping that eventually down the line it will really support clinical decision making in terms of rather than just taking the feelings out of making a best guess for what the next treatment for a patient should be. Just a little bit more information to provide the rheumatologist with an incentive to actually keep the patient on an anti-TNF, but more likely to move them off. And our goal is to have a patient and physician portal that will enable both to access the information and see how this can help them manage their disease. The last thing I'll say, and kind of relevant to Orion too, is the platform that we use is agnostic. We have captured information from, we have a lot of oncology information in our knowledge base, a lot of immunology, a lot of different disease information about different diseases is in there. And so, we've worked on a lot of these other diseases like SLE and IBD and MS, a lot of different types of cancers. And so in terms of developing a Clarify product or a Clarify approach, it doesn't have to be an RA. And so we're really looking forward to, identifying other potential data sets in different diseases and, maybe doing a Clarify SLE, et cetera. And I think that is it. I'd like to acknowledge my team. We're actually going to publish this work. It's under review, and the paper will certainly have a lot more information about the exact methods that went into this. The lead author on this is Ty Thompson, and the rest of the team, most people here are Solventa employees or have been working at Solventa, but are seen here. And Aaron Van Hooser was our last author. So I think that wraps it up for me. I would be happy to take questions.
So Renee, as we wait for anybody else to jump in here, I wanted to ask you, is there anything in terms of what you're looking at in terms of identifying impact on quality of life based on the different TNFs?
You mean, does there exist, or will the test really help us with any of that?
Well, yes. Will the test really help us to understand that?
Yeah, it's a really good question, and our hope is that mostly the test will just help you move off of the therapy when it's just not working. I think that in a way it's really good that we're starting with infliximab and trying to attack the TNF class first, because I just think that there's this endless cycle that could go on for, maybe up to years in terms of taking medication that's just not going to work, or it's going to, and what we'd also like to be able to do, and hopefully we could start to get at this with the disease activity measure, is to determine when your TNF stops working. So then you might want to take the test again at that point, so that could maybe help you make a decision there. In terms of things like, are we going to be able to predict when it's going to be really challenging to cut meat anymore, or, open the car door and things like that? We've actually tried, in terms of the disease activity work, to see if we could find changes in mRNA expression that were associated with very, very specific clinical elements like that. And we haven't been able to see anything yet. And I think a big part of that might also be because we're looking at blood. And, unfortunately, in the RA space, we all know that blood is going to have to be the biomarker. Taking synovial biopsies is not practical. It's very painful for the patient. So really getting at the core disease tissue, I think, is going to be a challenge. And so with this, we really face having to work with whatever signal is available in kind of a peripheral tissue to the disease. So I think that's why we're not seeing real associations with very specific kind of clinical issues.
Okay. And a second question that I have for you is, what about overlap with other immune diseases?
That is an excellent question. That's an excellent question, actually. So, and I didn't present this, but we talk about it a little bit in the paper. We did two things after we had ClarifyRA, and the first was to try and test it on other, other response data from different treatments. So they may not have been, we didn't have any other anti-TNF treatments, but, there were a couple of other ones, like I think there was an IL-17 treatment out there in the public domain. And unfortunately, we didn't really see ClarifyRA work for anything, ClarifyRA, the infliximab component, work for any other drugs that were out there, which, it could be because it's simply class specific or infliximab specific, which is what we would want, but, the patient numbers were also not very high. So it's impossible to say, but more directly to your question, we're really interested in looking at this for other infliximab-treated diseases, right? Like IBD or, spondylitis or something like that, where Remicade is a common treatment. So I think, we're hoping to be able to partner with some pharma companies to actually be able to do that. There's a little data that's available in the public domain. And, it does actually look like it's predictive, but I'm very wary of saying that because I think there were just some issues with how the samples were collected. I'm talking about some IBD data that's out there. There's really no middle ground there, that patients are either super responders or super non-responders. So I'm not really sure it's a fair test. It's a great question. We're really curious about that.
Yeah, I mean, I think that's of interest to everybody, and I mean, I think that all of the products that are anti-inflammatory in one respect or another come into this category, and I think we need to be, well, this is my opinion, and I'd like to hear your thoughts on it, but we should be looking at not only the underlying pathology but also the symptomatology, because that's what the patients are dealing with.
It is. And, there's this interesting consortium that's been generated in Europe called PreciseAds, and the entire function of it is to do really a molecular-based classification of autoimmune disease. And I'm really excited about this because they're looking at lupus and RA and a few other things. And the idea is, I think it is more focused on that. It's maybe not so much the symptoms, but the molecular biology of the patient rather than the clinical definition of the disease. And maybe that will enable you to find the lupus patient that's really going to respond to the RA therapy, or vice versa. So, hopefully in that way, it can be, more about what the patient is experiencing, rather than a classic clinical trajectory or algorithm that you're going to be forced to be put on. And the other issue, too, is a lot of these autoimmune diseases are very hard to be diagnosed with in the first place. And that's not something that we're directly tackling here, but, in our conversations with Andrew, even, it took him 2 years to even be diagnosed with RA. And that's 2 years where, it's easier to manage early stage disease. So, he could have been started on DMARD therapy at that point.
Absolutely. And appreciate all of your comments. I don't see any additional questions, so I am going to stop the broadcast. But I think that this was an extremely useful presentation. And Renee, if you can stay on the line for a couple more minutes, that would be great.
Absolutely. Thanks to the audience.